Okay, I'd like to examine a linear function one more time and just kind of summarize linear functions. So first of all, the equations we've done prior to now looked something like y equals 4x and y equals 2x minus 3. And I mentioned to you that I knew that those were linear equations because y was raised to the first power and so was x raised to the first power in the equation. So they have equal signs. Look at this one. 2x plus 3y equals 6. So it is an equation. The term that has x in it has 1 for an exponent. It's understood to be 1 when it's not written, and so does the y term. So I want to graph this linear equation, but it's not in this form, y equals something. So first of all, I could get it in that form so that I could more successfully put it into my graphing calculator. That would be the only way to do that. So let's go ahead and do that. So let's take 2x plus 3y equals 6 and solve for the letter y. Well, you know that I would subtract 2x from both sides to get this term out of here and 3y to be all by itself. Then I'll divide by 3 in order this to become y equals something. I kind of like to put my x term first here, so I'm going to put a negative 2x and then the plus 6. The 6 is positive, so I'm going to do that like that. And then finally, I'm going to divide both sides by 3. And when I do it on the right-hand side, I'm going to divide both of those terms by 3 so that I can see the fractional number that's in front of x. And then if this were a fraction, that'd be fine, but 6 divided by 3 is 2, and that's just a little bit easier to type into the graphing calculator. Plus, in the future, we're going to talk about graphing this equation as it is, it's now in slope-intercept form. But let's go ahead and graph the function that we've just rewritten, and let's pick some values for x that will be nice to work with. So you've noticed that I like to use 0 because a negative 2/3 times 0 is nothing. And then when you add 2 to it, you get a positive 2. That's called the Y-intercept. This 0, 2 ordered pair, and right here it means I go nowhere in the x direction, but I go up 2 in the y direction. That's one of the ordered pairs in this equation. Do you see this equation written in this form? That 2 will always be that y-intercept. If I tried a 1 right now for x, it wouldn't work so nice because a negative 2/3 times 1 is a negative 2/3. So I'd have a fraction that's negative and I'd have to add a whole number to it. So you see this denominator of 3? I'm going to put in for x multiples of 3 so I can cancel out the denominator. So multiples of 3 would be 3, 6, 9. So I'm going to go here now and put a 3 in for x. And when I do that, this 3 and this 3 cancel out. It would have been a negative 2/3 times 3, which would have been a negative 6/3. And a negative 6/3 is a negative 2. So what I have left there is a negative 2 plus 2, or 0. Let's now put in a 6 right here. Now I'm going to erase that for a minute. So this was a negative 2/3. Now I'm going to put in a 6. So, if you struggle at all with this fraction, I could call it a 6 over 1. You could go straight across here and call this a negative 12 divided by 3. This negative 12 divided by 3, which is a negative 4. And then you add 2 to it, and you'd get a negative 2. Of course, don't forget that you've got this tool. Let's see if I can put it right here. And so you can go right here and put in a negative 2/3, and you can just put the x in now, plus 2. And you can ask it to set up a table that starts at 0. And I'm going to go in increments of 3 because then I'll see nice numbers coming out. And then I'll go second and hit the graph key. And there's the 0, 2 that I just found right here. Here's the 3, 0. Here's the 6, negative 2. And this 9 right here would be a negative 4. Again, of course, don't forget you can hit the graph key and you can graph this equation. That's what our equation should look like here in a minute. And so let's go ahead and do that. So when x is 0, y is 2, we've already got that. When x is 3, y is 0. When x is 6, so I got to come over here, y is a negative 2. And it'd be hard for me to graph the 9 and down 4. But nonetheless, this does look like a straight line. And it does look like the line, I'm going to try that again. And it does look like the line that we just saw on the graphing calculator. I have to add my arrowheads. I didn't have any restraints on what I could put in for x. I just chose particularly nice numbers for it. All right, so before we leave this, I would like to have you compare the graphs of these equations on your graphing calculator. So we're going to go ahead, and I might expand the calculator a little bit. So let's go in here and hit clear, and let's graph y equals 3x. You know, I want you to remember that I've set my window to go from a negative 10, 10 with tick marks every 1 unit, negative 10 to 10. So watch, when I hit my graph key for the graph of y equals 3x, I just want you to see that in this direction I go all the way out to the left 10. And in this direction I go all the way out to the right 10. And then in this direction I go up 10. So if we counted these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pixels. In this way a negative 10. That's a standard window for graphing. It's kind of nice, especially for non-story problems. So when it graphed y equals 3x, it put a 0 in here for x, and 3 times 0 is nothing, and it plotted that point. And when it put a 1 in here for x, 3 times 1 is 3. So it went to the right 1 and up 1, 2, and right there is a dot. Right there is a dot. And over 2 and up 6. Let's go ahead now and graph y equals 2x right alongside. And that 2x is going to come in next. And I'd like to share with you now that the number in front of x impacts the slope of the line, how steep it is. So the 3x was this steep line, and the 2x was a little bit less steep. And then I'm going to go ahead and put in the third entry, y equals 0.5x, and watch how that one's getting to be kind of flat because that slope is so small. And finally, let's go in and put in 0.1x and hit the graph key, and you can see almost a flat line, very, very lightly inclined slope. Again, remember that's because here when you set up a table of values and you put in 0 for x, you get nothing. When you put in 1 for x, 3 times 1 is 3. When you put in 2 for x, you get 6. But watch this one right here. When you put in 0 for x, a half times 0 is nothing. But when you put in a 1, 0.5 times 1 is 0.5. Look at this 1 and that 3. 1 and 0.5. Much smaller y number. You put in 2. 2 times a half is 1. Here it was when x was 2, y was 6. X was 2, y is 1. So the change in y is not as great as here in this 3x equation. When I put negative signs in front, I just want you to notice, and I'm going to see if I can just go ahead. These were all positively sloping lines. They slope from the lower left to the upper right. I would like to go in now, and I'm going to insert negative signs in front of this. So to insert, see the INS above the delete key? I'm going to go second and insert. So right here in front of the 3, it's kind of blinking. It's got a flat line there. It's blinking. I'm going to insert a negative sign. And watch when I hit the graph key. Here comes y equals negative 3x. That's a negatively sloping line, whereas the rest of these are positively sloping lines. So that 3 is still as steep as the other one was, but the y values drop down for every increase in x value in that negatively sloping line. If I came here and inserted, let's a second, insert a negative sign in front of 2x, and I hit that graph key. There's the negative 3x. Here comes the negative 2x. But these other ones are positively sloping lines. In summary, in terms of linear equations, I just want to remind you that the domain of a linear function is all real numbers. That's what I like to write for that. If you wrote this in interval notation, you could say it's anything from a negative infinity to a positive infinity. I'm not going to use that so much, but it is common in a more theoretical math class. You can write the phrase out, all real numbers. And then what's the range of a linear function? Same thing. Anything can come out of that. You can write that symbol. You can write this. You can spell out the phrase all real numbers.